Hello, it's Joe Reese. I'm here to talk to you about why data engineering is the foundation of data-centric AI. So first, let's get something out of the way. So why should you care? So if you work with machine learning or AI, you need data upon which to do data science. This seems obvious enough, but we'll get into why this is sometimes ignored. And a big question you might ask yourself is, well, you need data, but how do you get data? And if you have the data, is this data of good quality? Is it reliable? Should you trust it? Is it believable? And so the question you need to ask yourself is, well, do you have the data to do your job and to build something great? So what we'll cover here is we'll describe what data engineering is and why it matters to you. We'll talk about the data engineering lifecycle and its undercurrents. We'll cover why data engineering is the foundation of data-centric AI. And finally, we'll talk about a few ways you can work with data engineers. So just a quick overview. Who am I? I'm Joe Reese, as I said before. I jokingly call myself a recovering data scientist. I've worked in all sorts of data roles since the early 2000s. In particular of interest to this audience, I've worked with a few auto ML startups, including one way back in the early years of the 2010s. And so, I'd like to say I've seen, at least the modern versions of machine learning since its infancy. And, I would say, that it's what got me into data engineering, actually. I was hired to be a data scientist at many companies. And, around that time, data scientists were expected to do very magical things. And of course, what I quickly realized was, engineering is really at the heart of machine learning and data science initiatives. So without proper data pipelines and storage and everything else that goes into data engineering, it's really difficult to do proper data science. There's a common trope that data scientists spend 80 or 90% of their time collecting data, cleaning data, preparing data, and so forth. And I really feel like this is where data engineering should fill the gap. Ideally, a data scientist should spend 80 or 90% of their time, doing the work they're trained to do, algorithms and, modeling and so forth, not necessarily the housekeeping and the engineering work that goes along with supporting these functions. So that's what motivates this talk today. Is I think a lot of my experience, working in machine learning as well as a data engineer. A little bit more about me. I'm CEO and co-founder of Ternary Data. We're a leading data engineering consulting firm. We have clients all over the world, as well as partners globally as well. I also moonlight as a professor at the University of Utah. And I'm a podcast host. My show, the Monday Morning Data Chat, features a lot of luminaries in the industry. I speak at conferences, blog. And most recently, I'm the co-author of Fundamentals of Data Engineering, which came out on O'Reilly this year. So let's get some housekeeping out of the way. Let's first level set and understand, what is data engineering. There's a lot of definitions. If you look online, you'll see quite a few. I pulled a few definitions online to sort of show you what I mean. So one definition is data engineering is a science of collecting and validating information data such that data scientists can use it. I think that's pretty good. Another one is data engineering is all about the movement, manipulation, and management of data. And so I'd like to have you ask yourself, what do you think data engineering means? Here's what I think it means. My co-author Matt Housley and I, we came up with a bit of a long-winded definition of data engineering. But we, when writing a book, you want to try and encompass as many ideas as possible. But essentially, it's development, implementation, and maintenance of systems that take raw data and provide it for downstream use cases, such as analysis and machine learning. So we'll talk a bit more about this, but it's also the intersection of a lot of undercurrents, such as data management, data ops, architecture, and so forth. I mean, at the end of the day, a data engineer, they take data from raw systems and raw data from systems, and they make it useful for downstream use. That's it. So let's look at how we got here with data engineering, right? So back in the 2000s and well before, you had ETL developers, database administrators, BI engineers, data warehouse administrators, and so forth. And these jobs were largely to serve the purpose of analytics, right? So you had data warehouses, and these jobs largely meant supporting these systems for analytics. And then around, say, kind of the 2000s to 2010s, you had the big data engineer, right? So this is a lot of these big data technologies spawned out of places like Yahoo, Google, Amazon, and many others. And the notion was, you have a lot of data coming in. You have to do something with it. This is also around the same time that I could argue, machine learning started being done at scale. And so the big data engineer was really, responsible for maintaining the systems that supported this, these large scale, data and ML projects. And kind of along the way, what was interesting is that, the data engineer started coming into the fold. And I think a lot of this had to do with the introduction of the cloud and, just data being more widely used across, companies of all sizes. The big data engineer was, I think, a bit of a misnomer in the sense where this is, I think, largely attached to companies that were doing things with data at large scale. But, with the cloud, you could start, adopting a lot of these same practices in much smaller data sets. And so, it's a rapidly evolving field. And along the way, you also had data science, AI, and ML come on the scene. And, these are all game changers. What this has led to is new practices. In engineering, you have analytics engineers, you have machine learning engineers, you have ML ops, and, and who knows what will happen in the future. But so why does data engineering matter? If you've been on the scene long enough, you've seen this image from Monica Rogati. This came out in, I like to say 2017, but she had this amazing article called the AI hierarchy of needs. And really, if you look at the top of the pyramid, this is where a lot of people want to focus is, AI and deep learning, right? And not machine learning and obviously other types of, practices. But at the end of the day, this is sort of the end state of data science. I remember, especially when I was coming up, in machine learning back in the early 2010s and early 2000s, but the term data science didn't exist back then. It was more just you either like doing, I guess, predictive analytics or something like that, or machine learning was still a it's all something else you call it, I guess. But data science really wasn't a thing. But now, data science started becoming, I think the term was introduced in 2009 by DJ Patil, and it started encompassing all kinds of stuff, machine learning and analytics and cleaning data and data pipelines and all this stuff. And if you take a step back, data science really, it's about getting value out of data, but you need to have the systems to do this. And so I like to say that data engineering really focuses on the bottom two parts of this pyramid. So provides foundation upon which you can do not just data science, but now, data-centric AI and ML ops and ML engineering and so forth. But it really is a foundation. You need to get data from systems, source systems. You need to, provide it in a consistent and, in quality manner, which is hard to do actually. So let's look at a step back and understand a couple things here. So, I kind of view data engineering as a life cycle. I think there's also maybe an equivalent life cycle with machine learning, but I won't get into that in this conversation. But really, and this is a data life cycle diagram that comes from HBR. You generate data. Data is collected, processed, stored, managed, analyzed, visualized, interpreted. Right. So this data life cycle talks about something that's probably more related to analytics, right? Step 6 and 7, analysis and visualization, interpretation. That's classically what a data lifecycle would achieve. But now with machine learning, a lot of change. I could argue that this doesn't go away. You've just added, maybe a few, tangents off of it, I suppose. So you have machine learning and AI and so forth, right? So the data lifecycle has gotten a lot more complicated. And I would say, the data engineering lifecycle has always existed in some form or fashion with this. It's just, maybe it's part of the maybe it's steps 1 through 5 or something like that, right? But let's look at this. One of the big ideas in the book was the data engineering life cycle, and so the notion is, when we wrote the book, we tried to understand. Okay, so in a rapidly evolving data ecosystem, what's not going to change in the next 5-10 years? So I was like, well, okay, I think systems will generate data. It'll still need to be ingested somehow and maybe transformed or queried or something like that, and served for end use cases like analytics, machine learning, and reverse ETL, and whatever else you want to serve it for, right? But then it's going to be stored in some fashion along the way too. And so, these are sort of the buckets into which you could think about lifecycle management for data engineering. And then, of course, the question I'll ask you is, for machine learning engineering and data-centric AI, what follows on that? There's this serving part here, this yellow box that talks about machine learning, but that's got its own life cycle after that, right? And but the data engineer really focuses on getting data, doing something with it, and providing it for downstream use cases, and I would argue other life cycles. But undercutting the data engineering life cycle, this is very interesting. So when you look at things like security, for example, this doesn't really just happen at generation or ingestion or serving. I mean, this happens everywhere, right? I could argue it should happen everywhere across other data life cycles as well, machine learning life cycle and so forth. Same with data management. It includes things like data quality and data ops and architecture and all these considerations, right? These are all things that happen at various parts in every part of the life cycle, not just one. And so when you think about data engineering, think about, ingesting, transforming, serving, and storing data, along with like, how are you going to secure it? How are you going to manage it? Data ops, how does that work? How are you going to know that a pipeline's failed, for example, right? Architecture is another big one. How do you design systems that, are resilient, cost effective, but incorporate maybe reversibility and modularity? Especially in a fast changing world, architecture is a very interesting subject. You don't want to get too pigeonholed into certain architectures. And I know the same thing happens with, AI infrastructure and architecture as well. There's, that's a fast evolving field as well. And orchestration, how do you orchestrate things along the life cycle? And finally, software engineering. How do you, write good code that's performant, as free of bugs as possible, and is reproducible and so forth. So the data engineering lifecycle, I think, is a really big idea I'd like to hone in on with respect to data engineering being a foundation for data-centric AI. Again, we talked about the undercurrents, but I'd like to touch on these a bit more. There's a lot to undercurrents. So security, right? These are access to data and systems, data management. This is a huge topic. There's the DAMA Book of Knowledge, if you ever wanted to, explore a 600-page tome on all aspects of data management. But I encourage you to do so. It has a lot of best practices that I think apply both to data engineering as well as analytics and machine learning. So a lot of this has to do with data integrity and quality, right? A big piece of data-centric AI has been that we're moving into an age where we have to focus on data quality and integrity, and data management provides these pillars. Data ops provides the pillars of also of governance and observability and monitoring and incident reporting. It's very similar to what DevOps has done. Architecture is about analyzing trade-offs, designing for agility and adding value to the business, right? And orchestration, is how do you keep everything moving together in a coordinated workflow? And again, like software engineering, like I said, it's about having, great software design patterns and testing and debugging. So, which means you're not writing, hacky code. It's about writing stuff that produces, great systems. So let's talk really quick. A data engineer, who do they work with? Well, upstream, they're probably working with software engineers, application developers, product managers, project managers, and so forth. These are the people that are usually providing them data and or requirements, for what needs to be done with the data. Downstream, they talk to analysts, data scientists, ML engineers, and ML ops professionals. And so, as a data engineer, your job is you sort of sit in the middle. You need to understand the data that's provided to you and how that happens. And downstream, you need to understand what do your stakeholders need. And so then you're also talking to the business. This could be executives, stakeholders, or similar. These are the people who are usually making budgetary decisions, about how data is being used, and strategic decisions about how, these data products will be deployed. So it really helps for you to understand, whether you're a data engineer or whether you're, the machine learning side, but who are your upstream and downstream stakeholders, right? And also pay attention to who's writing your checks at the end of the day. This is something that I see a lot of engineers and data scientists, often ignore, and often at their own peril. So some of the challenges with data-centric AI, right? It's just the reality of data. It's messy. It's often hard to get. It's obtained and maybe served inconsistently, right? I mean, you have no guarantee of how often data is going to show up or in what form. And the big question is, who owns data through its life cycle? This is a central question where, if you're talking about your upstream and downstream stakeholders, you really do need to understand who owns the data at that stage in the life cycle, right? If you're getting data from a software engineer, do they own the data that happens to be in an application database? Or is that chain of custody, through the life cycle of that data as it's moved through different systems? And finally, who owns the outcomes? I can't say that it's any particular person, but all stakeholders of data should be communicating about expectations, and anything related to the data along its journey. So why is data engineering the foundation of data-centric AI? Well, I mean, as Andrew Ng pointed out, in his article about data-centric AI, is that AI is no longer just about algorithms, right? I think we've moved beyond the point where, data science is completely focused on, algorithms. It used to be the case where algorithms were king, and I remember back, in the early days of kind of modern machine learning, where people would, say it's all about the algorithms, so we just need to throw more data at the problem. I think now it's maybe that's somewhat true, but the recognition is also that we're moving beyond that, right? It's more about what data has to go into the algorithm, and is this the best data for this algorithm? And also, how do I reliably get the best data on a continued basis? This is a challenge I had in my career working with machine learning products. Is often, our company was based upon getting unseen data sets and making predictions on them. Usually tabular data, somewhat semi-structured data, but this is a hard problem. When I got into this back in the early 2010s, it was that was a hard problem back then, and I realized the algorithms, even at that stage, that was at least the worries. I think this is before deep learning. We're doing stuff based on support vector machines and more tree-based models. But the challenge was always, okay, I get a data set from a company. No two data sets are alike. Typically, data is, especially when talking about tabular data, it's got all sorts of quirks in it, right? You got to understand, this is human generated data in tabular form. That are structured oftentimes by, maybe DBAs, right? And maybe data quality checks are or are not there. You just never know what you're getting. And so data quality is one of these things where I would say it's a lack of data quality is a rule, not the exception in these circumstances. And then the next part is, well, how do I get the data in a reliable fashion, right? So you couple this together, and it's like, if the goal of data-centric AI is to focus on data, then the goal of data engineering is to provide the highest quality data in a reliable and consistent manner. That's the bottom line. Good data engineering enables good data-centric AI outcomes. I would like for you to think about when the opposite case is true, actually. So, I guess, think to yourself, when would there be a case when you don't need quality data, and you can simply throw algorithms at the data? So let's just kind of talk about some ways that you can work with data engineers. I'm assuming that the audience is kind of leaning more towards machine learning practitioners and so forth. And with me having sat on both sides of the spectrum, I can kind of attest to some ways that I found my role to be successful. And in my consulting practice, when I see data teams working together, I can echo a lot of these practices are ways to be successful. And so, again, focus on outcomes, right? At the end of the day, you're building a data product of some sort, right? So focus on what that end-to-end data product looks like. This also includes the workflows that produce that product, but focus on what's it supposed to do, and make sure everybody involved with the data knows this. The worst thing you want is for people who are responsible to get you data to really not know, or probably not care about what you're going to do with it. Like they should at least know, what you're trying to do with this data product. On that note, use data contracts. So data contracts are really a way of enforcing predictability and expectations with the data that's being provided to you. So this could just be as like, I need data, maybe once an hour, and it needs to take this shape of form with this schema, these value types and so forth. If you're dealing with images, at what rate am I getting images? What are the sizes? And so forth. But really just make sure that you set expectations with your upstream data providers, typically data engineers, about what you need. And I'd also say set tests and automations in place to trigger notifications when data contracts are being violated. This is another big thing. Understand where you operate in the data lifecycle and how the data engineering lifecycle works. Again, I always like to say that data engineering is basically lifecycle management at the end of the day. And so if you can understand how lifecycle works, this makes it a lot easier to avoid tool fixation, for example, which is the next point. So technology should always be the last of your concerns when working with data engineering or any other stakeholders, right? So focus on people and processes and then technology. The easy thing to do is to focus on what tools you're going to use, often without the context, say of the data product you're building or the data contracts that you're enforcing. Choosing tools is probably the last thing I'd do. It usually is a recipe for disaster because you're taking a very short-sighted view of the data product. Finally, decide who does what, right? So in some cases, the lines between data engineering, ML ops, and ML engineering and data science are very blurred. You need to be very clear about who owns what. So I would suggest making a fake org chart, or if you have a real one, then use that. But just write out, okay, so I have roles for data engineering, I have roles for ML ops, ML engineering, data science, and so forth. And put names to this, right? So a certain person might be doing the data engineering part. That same person might also be in charge of ML engineering just due to, team constraints. Maybe it's a small team. And so that person has to have overlap. That's entirely possible, but just understand who's doing what, right? This avoids a lot of stepping on toes and it also makes the notion of data contracts much more clean, where when there's handoff, again, along the chain of custody of data, back to the notion of who owns what. Now you know who the directly responsible individual is along each stage of the life cycle. And so to recap, data engineering is the foundation for data-centric AI. It's important for you to understand the data engineering lifecycle and its impact on machine learning and AI. Data quality and reliability, it really does matter. At the end of the day, data engineering should be responsible for providing the highest quality data in the most reliable way. And the other takeaway is just work together with data engineering, right? Just understand who does what, have clear contracts, clear understanding, talk regularly, especially if there are changes. And I wish you the best of luck, in your data-centric AI journey. If you have other questions, please get a hold of me. I'm Joe Reese you can email me at joe@ternarydata.com. So thank you very much.